All right, I think we're good to go. All right, so thanks for joining. Today, we are going to start hypothesis testing. So this is the second last learning unit for this module. So we're almost at the end. All right, so let me share my screen and tell you what this is all about. And if you can't see my screen, just let me know in the chat. Okay, so I'm going to share the whiteboard. Okay, so we'll talk about this learning unit by looking at a problem, all right, and what this learning unit is all about, and the content that's basically used to test a hypothesis. As the name says, hypothesis. Hypothesis means an idea. It's something you you hypothesize, or in other words, you have this idea, you have this theory. And in science, you know, that's a very common thing. You have this theory and you wish to test it. And when you say test it, you want to test whether it's true. Now, what this learning unit is all about is how to go about testing that theory using data. So for instance, like if someone claims, you know, out of every 1,000 cars that come out of this factory, only 2% of them have a defect. All right, so you'll hear claims like that in the industry sector and in various other sectors. Now, how you actually come about that number, that 2% number, and whether to test whether that claim is true, that's what hypothesis testing is, and how you can go about using data to test that theory. All right, so that's what hypothesis testing is. So in this example, we're going to test a claim, and it's a bit different, obviously, to the manufacturing example I gave you with cars. Now we're going to talk about visitors to a mall and how much they spend on average. All right, so I'm just going to check the chat if there's any questions. We can see. Okay, I'm assuming everyone can see my whiteboard and they can hear me. All right, so let's look at this question. This is a typical kind of question you get in your exam. All right, so I'll read it to you. So there's a manager of a large shopping mall. Doesn't matter where it is. Chat. Hey, Taya. You just want to say hi. Thank you. Any issues? But I'm assuming everyone can hear me. All good? I'll go back to the whiteboard. It's kind of difficult to see both screens, so. All right, thank you. All right, let's get back to it. So now we have this manager of a shopping mall, and this manager believes that visitors to the mall spend on average 85 minutes. Okay, that's how long they spend in this mall on average, right? On any one occasion. Now that's the theory. That's what this manager hypothesizes, and we want to test this. So to test this belief, the manager commissioned a study which found that from a random sample of 132 visitors to the mall, the averaging visiting time was 80.5 minutes and assumed the population standard deviation of 25 minutes. Okay, so before we just read on further and continue, right? So just think about this logically, right? If someone says, hey, just think about that example I gave you earlier about the claim that in this manufacturing plant where you got 1,000 cars and only 2% of them have a defect, right? If, say, for instance, we find 1.99, so let me write it down to give you an idea, right? So they claim 2% have a defect, right? Right? But let's just say we just took a sample. Instead of looking at 1,000 cars, we just took 100 cars. We took 100 of them, and out of those 100, we found the percentage that have defect is 1.98%. Now you can see it's very close to this. So, you know, you wouldn't be inclined to say that this is wrong, okay? We expect this to be an close value or an estimate. We don't expect it to be exact, but at what point do we say, no, it's not true? Is it 1.97%? Is it 0.5%? I think all of us would agree that if this is what we measured and this is what they claim, then we would say it's not true. But these two are very close, right? So in the same example that I used here for the manufacturing, let's just look at the shopping example, right? So what happens is this manager claims that on average customers spend 85 minutes. Okay. So the claim is that the customer spends on average 85 minutes. Okay. But what we did, we can't spend the entire day at the mall and monitoring every single person that comes to the mall. The best we could do is we could just take a sample of them, right? So we take a smaller sample, we just look at 132 people, right? So this is the full population, which we can't really count. So the best we can do is we take a smaller sample of 132 people. And out of this 132 people, what we found is that the average shopping time for these people, right, the average shopping time is 80.5 minutes. Right, so that's what's given here. That's what the average is. So if you look at this, it's 80.5 and this is 85. It's pretty close. It's like about 4.5 minutes off. And is it enough to say that what this manager is claiming is false, right? I think we all can agree that if the time was, say, 60 minutes, that's quite a big difference from what they claim. And we could say, no, it's not true. If it was 30 minutes, we would say undoubtedly, no, it's not true. But 80.5 is pretty close, right? And there's a point to this, to what I'm saying, because it's so close as to what they claim, we need to test it statistically based on some threshold, okay? And when I say some threshold, I mean some cutoff, okay? At what point do we say it's not true? And that's going to be given to us further down the question. All right, so does everyone understand what I just said so far? So what happens is the manager claims that the shopper spends on average 85 minutes. We took a sample and we found the average to be 80.5. So it's not too far off. Okay? It's pretty close. But what we're going to test is we're going to test statistically based on some threshold whether we can accept this manager's claim, or we can say, no, it's not true. Okay, that's what we're going to do. Okay, does everyone understand? That's what I've just said. You don't have to understand how I'm going to do it, because I'm going to explain that to you in a few minutes, but just what we're trying to do. Okay, thank you, Shleganipo. All right, I hope that makes sense. All right, so now we're going to go about testing this. So I'll go back to the whiteboard. All right, now the question says, formulate the null and alternative hypothesis to test the situation. All right, so what we're going to do is we're going to formulate, or basically state mathematically, what we are testing. That's what question A is saying. Okay, state the null hypothesis, which we denote as H0. That's the null hypothesis. And then the alternative hypothesis is H1. That's your alternative. Okay, H0 is your null. And so this is your null, H0. And this, the alternative, is your H1. Okay. Now, what the manager claims, this manager says that the visitors to the mall spend on average 85 minutes. So the average, and this is a key word here, average. So this manager believes that the true average, in other words, mu, is 85. And that's what H0 is. Mu equals 85 minutes. All right, I don't have to write minutes, you just need to write 85. In the end, when you interpret it, you just need to know it's minutes. And H1 is the opposite of this. So if whatever you have in H0, H1 will be the opposite. So if mu is equal to 85, then the opposite of that is mu not equal to 85. When you write not equal to, like this. That's the alternative hypothesis. So this is the manager's claim. The manager claims that the average time spent shopping or at the mall is 85 minutes. That's what question A is all about. Formulate the null, it means state what your H naught is, and your alternative hypothesis, which is H1, right? And that's what we've done for question A, right? Question B is, which test statistic, Z or T, is appropriate for this test and why? Let me go to the chat before I continue. Okay, no questions. All right. So go back to the whiteboard. All right. So which test statistic? Okay, so what you need to know, so this is question A that we just answered. For question B, what you need to consider is, first, are we talking about averages? And the answer is yes, okay? Because we read the text in the question, they're asking us to look at the average time spent in the mall. So are we dealing with averages? So that's yes. So I'm just going to write that down now. Question B, are we dealing with averages? It is yes. And the next part that you need to look for is the sample size. Is the sample size greater than 30? We denote the sample size by n. Is it more than 30? To read the question, it says a random sample of 132. So yes, our sample size is bigger than 30. Okay, it is. So if that's ticked off as well, if these two are ticked off, that means if you're dealing with averages, and if your sample size is more than 30, then that means you use a Z statistic. Remember that. Okay, please make a note of that somewhere. You need to learn this off, right? So if these two conditions are met, that is, are you dealing with averages? Is your sample size more than 30? If so, you're using a Z statistic, right? Okay. So that's the answer for question B, right? We'll talk about the T statistic in the next problem, but that's right now. Go on. Okay, good. Right. Okay, so question B, we use the Z statistic. Now, question C is the bulk of this question, right? And that's where you're gonna score the most amount of marks. It's gonna be a lot of calculations and interpretations, etc. But it's the bulk of your workings for this question. All right. So question C is conduct a hypothesis test for a single mean at a 5% level of significance to support or refute the manager's claim. What management conclusion could be drawn from these findings? So what this question C is telling us to do is go ahead, look at what's given, and test whether this manager's claim is true or not. That's what C is telling us to do. So we're going to proceed answering question C. All right. We've already stated the hypothesis. That's done here in part A. Question C, we're going to move on to finding the rejection region. Right. So in hypothesis testing, right, when you come to this learning unit, let me just create a new whiteboard. There are 5 steps to hypothesis testing. Right. Step 1. There are 5 steps. Step 1, formulate the hypothesis. In other words, formulate hypothesis. In other words, state your H naught, state your H1, right? That's step 1. And if you look at what we've done so far, we've done that for question A. So this is step 1. We've already done step 1. Okay, right. Then the next step is to find your rejection region. So step 2, find your rejection region. And that's your step 2. So we're not there yet, but we'll get there. Then there's step 3. Calculate the test statistic. Step 4. Okay, we're going to either going to accept or reject H0 based on what you find in step 3. Based on step 3. And then the last step is interpret and conclude. I will walk you through each of these steps now, so don't stress about it. Interpret and conclude. All right, so we've done step 1, formulate the null hypothesis. Right, we've done that. That's shown here in question 8. This is step 1. Okay, now we're going to move on to step 2. Step 2 is find the rejection region. Okay, so remember from what we just answered in question B, we said it's the Z statistic. So in other words, your rejection region is going to be based on using the normal distribution. In other words, the Z table on the back of the book. So I'm going to draw that graph. This. All right, that's centered at 0. And this is your Z axis. So basically, the graph I'm drawing is this here, your normal table in the back of the book, which we've done in the last 2 live sessions. Right, all I'm doing is trying to sketch this curve. I know my curve doesn't look like that. I did it freehand, so it's the best I could do. So please forgive me for that. So I've drawn that curve, right, on this board here. Right, so that's the sketch of the Z, the normal distribution. All right. Now, there's a key bit of information they give us in part C. They tell us 5% level of significance. Now, that 5% level of significance is important because it tells us how big the rejection region is. And I'll show you how to use that 5% now. So the 5% level of significance. Now, that 5% gets allocated to the ends of this graph. So what happens is we allocate part of it on the left extreme and a part of it on the right extreme. And what the size of each of it is that 5% divided by 2, because we're going to use half of it on the left and we're going to use half of it on the right. So in other words, we're going to have 5% divided by 2, which is 2.5%. And 2.5% here. And the reason why we split into 2 parts is because of this key, what do you call, symbol that we have for your H1. Whenever you see a not equals to, that means it is a two-tailed test. Okay, it's a two-tailed test. In other words, it has 2 rejection regions. Okay, it means it's a two-tailed test, and that rejection region is on either ends of this graph. Half of it is on the right, and then half of it is on the left. So whatever your alpha is, you split it into 2 equal parts. So it's because it's 5%, we split it in half, which is 0.025 on the left, 0.025 on the right. In other words, 2.5%, 2.5%. All right, we need to check the chat. Okay. Okay, so that's a sketch of this curve. And like I was saying, these extremes on the left and on the right, that is your rejection region. Okay, so that means anything from here and to the left, we reject H0. And the same here. Anything from here and going off to the right, we reject H0. But anything in between, we accept H0. Okay, so everything in between here, we accept H0. Right? So I'll show you how to use it now. Right? How to use this region to determine whether to accept or reject H0. What is important, what's your takeaway from this part, what I've just done here, is that you need to know that because it's a two-tailed test, based on what that sign is for H1, that means that not equals to. That means you have a rejection region on the far left, as well as a rejection region on the far right. And the size of that rejection region is your alpha divided by 2. In other words, the area of that rejection region is your alpha divided by 2, which is your 5%. This 5%, this is your alpha. That's your alpha, right? That's your level of significance. Right? We split this into half on the left and half on the right. Okay, now we know the area. Okay, but before I continue, are there any questions? Because it's going to get a little bit trickier here. So I need you to make sure that you're all with me until this point. So you want me to go back and explain anything? All good? People, in what case would it not be a? We're going to get to that. That's a very good question, but I'll answer it now. Okay, but we're going to get to that. The cases when it's not a two-tailed test, instead of having equals to and not equals to, you could have a case where it's greater than equal to and then less than. Now, when you have, these are inequalities. When you have inequalities like this, then it becomes a one-tailed test, right? But when you have equals to, strictly equals to, and not equal to, then it's a two-tailed test. This example is a one-tailed test. And we're going to do that next. Good question. Let's check the chat again. Okay, all right. I'm assuming everything's okay. And remember, if you don't ask me any questions, you don't let me know what you're struggling with, and I won't be able to help. You've got to let me know. Please explain what significance level means a bit more. All right. So significance levels is it is basically the size of your rejection region. All right. So let me give you some sort of context of this. I'll do. Well, let me actually put a new board. Okay. So say this mathematical symbol for significance level or level of significance, right, is alpha. It's the same. It's alpha. That's your level of significance, right? Now alpha can be 5%, can be 1%. Let's start with the smallest going to the highest. Can be 1%. Alpha can be 5%, and alpha can be 10%. It can be different values, but these are the most common ones. It can be take on other values, but these are the most common. Now, what they mean, right, in terms of the problem, right? Now, let's just draw it for alpha is 1%. So here's your curve. And then I'll do it for 5%, so you get the idea. So for say this is the 1%, and this is the 5%. And we're dealing with the two-tailed test. So 1%, this is 1% is much smaller than 5%. Okay. So if we split this 1% into 2, that becomes 0.5% here. Remember, we're splitting in half, so it's 0.5%. And then here, it's also 0.5%. And then in this case, now it's 5%. So in other words, it's slightly bigger. Let's make it bigger so you can see the difference between the top graph and the bottom graph. Now it's 2.5%. And here, it's 2.5%. Now you'll notice, remember, as we did in the earlier sketch, from here to here we reject H0. Right? And here onwards we reject. It's the same with the top. Here we reject. And here you also reject. But you can see that this graph in the bottom, let me sketch this in green. This graph from here to here, it's a shorter distance or shorter gap compared to here to here. Right? The top one is much bigger. That means you have a much bigger chance of accepting H0 here. You got a bigger chance of accepting H0 here because look how big the area of acceptance is versus here. Here it is a lower region of acceptance. So what that means is when you want to be stricter to whether you want to accept H0, when you want to be more conservative, right? Whether you want to accept H0, right? Or you want to, what do you call it? Err on the side of caution. Maybe I'm not pronouncing it correctly, but you want to be conservative, you want to be safer, then you would have a larger alpha. In other words, you'd make a larger level of significance to accept that H0. That means you want to be more confident that you can accept H0, all right? Versus you're a bit more lenient, you're not as conservative, right? So you would choose a smaller alpha. That's why you have a bigger region on the top. Does that make sense? When I mentioned earlier, you have those thresholds to test something. That's what your threshold is. Your threshold is your alpha. Your alpha tells you how much of a difference are you willing to accept. Everyone, does that make sense? Good question, Stagonido. Very good. All right. If there's no questions, I'm going to move on, but so assuming everyone's following. All right. Now, coming back to but thank you. All right. Now, where was I? Oops. A lot of things going on here. All right. Coming back to this graph. Now, we sketched this curve, right? And we showed that anything from here to the left, we reject H0, and anything from here to the right, we reject H0. But what we need to figure out is what exactly is the value here at this boundary on the z-axis, on this axis. What's the value on this axis for here and here? What is that value? That's the cutoff. All right, so now what we're going to have to do is we're going to have to work backwards to what we did in the previous session. So previously, right, what happened is what we would be given. Let me just get a board and make a new board. Before, in the previous sessions, what we would do is we would have a curve. All right, this is our z-axis, right, and it's centered at 0. We would be given the z value. So say the value was 1.9. Okay, we would know this value here at 1.9, and we would go and use the table to find the area. I'll shade this area in a different color. We would go into the table in the back of our textbook, and we would get back the area. Okay, we would go and find the area. So for instance, if the z value is 1.9, right, we want to know the area from 0 to that z value. We would go to our table. So there's 1.9 here. Z is 1.9. All right, there's nothing after the 0.9. It's only 1.9 exact, so that area is 0.4713. In other words, this blue area is 0.47, 0.4713. Right? Now we are doing it the other way. Okay, what we have to do now is we have our same curve. Right, centered at 0. Instead, okay, Z the axis. Okay. Now we know the area. So say we know this area of 0.4713, and we got to go and find what is the Z value. So you got to work backwards. In other words, you look at this table, you look for where the area is 0.4713, and you trace back the Z value. So the Z value corresponding to that is 1.9. All right, we're going to work backwards now. Okay, let's keep that in mind. That's what we're going to do. So if I go back to my board here, if you look at this mark here, that put in this axis, okay, we know that the area on the right is 2.5%. So what is this area here after the 0? Remember, half the area of this graph is 50%, right? Half of it is 50%, right? So what I'm asking, what is this blue area here? If the entire area on the right of 0 is 50%, and this is 2.5%, then this must be the remainder, which is 0.475. Everyone understand that? Okay, remember, half this area is 50%. We have the green area, which makes up 2.5% of that 50%. So the remaining area is 0.475. In other words, we know this area is 0.475, right? Just like how I did in this graph here. Okay, we know this area now is 0.475. So what is the Z value that corresponds to that? So we go to our table. We look for where the area is 0.475, which is here. There it is. All right, I'll make this a bit larger. So there's 0.475, and that corresponds to a Z value of 1.9, and the column is 6, 1.96. So in other words, that Z value is 1.96. Right? That's what the Z value is. So if I go back to this curve, right, that value that we were trying to figure out on the axis, this value here, this value is 1.96. Does everyone understand that? Very good, second neighbor. Yes, very good. That was the area size. Everyone? Fantastic. All right, so let's get back to the board. So if you know the value on the right, you don't have to work out the value on the left. It's very easy. All it is, it's a mirror image of each other. Whatever the value is on the right, the value on the left is just the negative of that same value. Because remember what we said about symmetry, right? It's the same thing on the right of what you would see on the left. It's just the negative Z. So here, this is 1.96, then this is negative 1.96. That's what the value is. All right, that's the cutoff we have. That's all cutoffs. And that's step 2. Now, step 3 is to go and work out what the test statistic is and check where it falls in this region. And to work out the test statistic, it's actually very easy. I'm going to, let me just make some space on this board. Okay, so remember we're doing the Z statistic. And the formula for the Z statistic or hypothesis testing is what we did last week. And that formula is Z equals X bar minus mu all over sigma over square root n. That's all we got to work out. And the values to feed into this equation is given to us in the text. Okay, for instance, it says a random sample of 132 visitors. So that's your n. Okay, this is your n, 132. And out of this 132, you found the average of that sample to be 80.5. So in other words, this is your X bar. Okay, so I'm going to stand this right here. X bar is this. All right? Your mu. Right now. Your mu, this mu here, all that is whatever is in your hypothesis, whatever the claim is, and that's 85. So that's your mu. Your sigma, you read the text, it says standard deviation 25. So that's your sigma. Right? That's your sigma. So we have our sigma, we have our n, right? There's our n here, 132. You got your X bar and you got your mu. You plug all those values into the formula, right? And if you do that, you'll get a value of now minus 2.07. Minus 2.07. Right? Plugging all those values into the equation. X bar, sigma, n, as your n, and then your mu is just what's in the hypothesis. You got all the values plugged into the equation. You do that and you get minus 2.07. Now this is you've done pretty much all the hard work, right? This is actually the easy part, is just interpreting it. You've done step 3, this is step 3, what we just did. Step 4 is look at what you had in step 3 and compare it to where it falls in this region. So look at where it falls. Does it fall in this area here? And the answer is no. This is minus 2.07. So this is more negative than minus 1.96. It's even further to the left. Right? Minus 2 is definitely on the left of minus 1.9. It's more negative. So it's somewhere around here. It doesn't have to be exact. All you need to know is where does it fall? Does it fall in this region, 1? Does it fall in this region, 2? Or does it fall in this region, 3? And you can see it falls in this region here, because it's negative 2. So it's somewhere on this side. So because it falls here, that means it's in the rejection region. So in other words, we reject H0. Right? So your step 4 is just simply saying reject H0 because minus 2.07 is in the rejection region. Or in other words, you could just say it's more negative than negative 1.96. You don't have to write this part. This is good enough. But you just need to know how to determine that. Does that make sense? It's very important you understand that. Everyone? Did you understand how to compare what you got in step 3 to your rejection regions to determine whether you're going to accept or reject H0? Fantastic. Okay, very good, very good. All right, and then the last part is just wording. Okay, it's no math. It's just interpreting what you got from the calculations and then making a conclusion. All right, so here I'll just make some space on this whiteboard. I really cluttered it, but I had to. Okay, so I'm gonna clear up as much as I can here. I don't need this. I just need that part where I'm saying reject H0. Okay, that's what we decided. I need this too. Okay, so we know we reject H0. So that means if we're rejecting H0, there's H0 here. And if we are rejecting it, we're saying no, we do not believe that. So we're saying that the manager's claim is false. That's what rejecting H0 means. We're rejecting whatever is in H0, and that's what the manager claims. The manager claims H0, right? So we would say it in words, and how you would do it, start your conclusion by saying at whatever level of significance you're talking about. So you would say at, remember, we're talking about a 5% level of significance. At a 5% level of significance, right? Start off by saying that, and then you would say we reject H0. That's what you found in step 4, right? Therefore, you can actually, if you want, you can say, you can ignore the reject not if you want, but I'm going to put it in here. You could just go and, you can just directly say we reject the manager's claim, right? But I'm just going to add that extra part here. We reject H0, therefore we reject, we can say we do not believe the manager's claim that average time in the mall is 85 minutes. That's it. That's how you conclude it in your last step, step 5. Okay, that pretty much just putting it in words. That is your step 5. And this question is answered. Everyone, makes sense? Is the test? Test. So, 1.96 is your critical value. Okay, that's your critical Z value. Minus 2.07, that's your test statistic. So the test statistic is what you get from the sample. The critical value is what is derived from the level of significance. Okay, so your 1.96 is your critical value, and the minus 2.07 is your test statistic. Right, does that make sense? Okay. Okay, so I think, yeah, I think I'm going to call it there. I'm not going to continue with the t-test. I'm going to do the t-test next week. Okay, but in practice, who determines or sets them? That's given to you. It's not open to interpretation. In practice, but you're asking in practice. Okay, so good question. In practice, it's often we often use 5%. 5% is the most common level of significance used in practice, unless specified otherwise. Okay, so it depends how strict you want to be in your test, but majority of the time it's 5%. But in the exam, you will be told exactly what level of significance to use. Right. Okay, I'm going to leave the floor open to you for any questions. Is there anything that you're not sure about, you want me to go back and explain? I'm not going to move on to the t-test. I'm just going to leave that for next week. I think it's a bit too much for tonight. But from what I covered this evening, are there any questions? Otherwise, all good. Once, twice. Okay. All right. In addition to this, please, this is a reminder, please complete all the ICE tasks. You have more than enough time. You've had more than enough time to complete them. I think your first ICE task is due 30th of this month, and then the others are due somewhere mid-May. But you can complete all of them now. You don't have to wait till then. Remember, those ISTARs only test you on, I think, like learning units 1, 2, and 3. So you've covered those learning units already. So you're definitely able to do it. Rather do it now than doing it later on. Okay. Other than that, that is it from me. And yeah, have a good evening, everyone. I have a question. Let's say when dealing with economic research, with the second thing. It certainly depends. You're welcome. Thanks, Tara. It depends. It really. So I can't really answer for economic research because I haven't been involved in economic research. But it depends on the study itself, like whatever the topic is. Even if you say economic research, it doesn't generalize it. Well, like, what of the economic research are you looking at? It could be income, could be poverty levels, could be, there's such a variety of topics that you could cover. So it actually depends on the study and setting that level of significance. Yeah, it's not a one size fits all, unfortunately. I wish I could tell you that, but I'm not sure. Like if for a medical study, that the level of significance could be different. Like if you're trying to determine a disease or something like cancer or some response to a medication or something, that level of significance could be much different if let's just say that pharmaceutical company wants to be a lot more confident in the effectiveness of something or in the test. Yeah. So yeah, that's my advice. All right. You're welcome. Have a good evening.